No, not according to
Well, welcome everybody. Glad you could make it. Hope you enjoyed our latest exhibit, the display of the Mound Closure Project and the D&D of Mound with the dumpster out front. I thought that added quite a bit. So, speaking of the D&D and the closure, we've got a former Mounder here that, like some of us, started a business when Mound closed. Back in 95, 96, started these businesses. Bill Bankus started with Global Manufacturing, and then that morphed into Global Foam Company. And so I think you'll be interested to hear his talk. He's probably one of the only businesses where you have seen their products. You may not know it's his, but if you've been to Great American Ballpark or Kings Island or up the highway, you've probably run into something that he was involved in. So I want to turn it over to Bill Bankus.
I'd like to thank you all for coming. I'd like to thank Doug for inviting me, and thank the folks that have kept this museum open all these years with their voluntary time and efforts. And it's going to evolve, I guess, into something a little different, but still all together it'll be a museum, maybe in two places. So my name is Bill Bankus. We started out as Global Manufacturing Solutions here on the Mound site. I'm going to talk about the early history on when we started and what got us started. We had changes in focus, changes in partnership, changes in location. Many development projects. And then we developed our business model for what we eventually became and evolved into 7 different markets, spinning off the EPS from the development projects, became 2 companies. And I want to talk a little bit about the secrets to our success. I read the Bronze documentary, and I'd like to thank Tom Shishia for coming. He's going to be the fellow starring in the documentary. I'd like to thank Fred for showing up. He's our partner for all these years. Chuck couldn't make it. He's still back in Pennsylvania, and I thought he would make it, and he didn't quite get here. And my wife Eileen, who was an integral part of the company as well, as we evolved and had all the people we needed to make us a success. Then we transitioned 5 years ago with new ownership. So let's go to the early history. We were founded at Mound in 1996 as they were shutting us down. They had we call it an open house. And I had a business plan to do something with molded plastics, just something we were trying to create. We saw all the opportunities here, and that's what excited us. You know, all the excess equipment and the great PhDs in science and technologists and engineers. And we thought, well, we should be able to do something with what's left of the site. So we gave business presentations, wrote business plans, and had an open house. And some fellow showed up for the open house, and I knew who he was because he was in total quality management, as we had we were part of a society, and I'd met him before. His name was Mike Gibbons, and he showed up. He was all excited about the open house, and then afterwards he said, look, we should do this inflator project. And I was like, well, that's a pretty big project. And he introduced himself, and we got to know each other, and we went to breakfast for like 2 or 3 weeks on weekends, and pretty soon I'm starting to realize who he was, because his name was MJ Gibbons. And he said, you know, you go downtown and you see the arcade, it says MJ Gibbons. That was his grandfather. And I was like, okay. Grew up next to the Ketterings. All right. Went to Kettering's 80th birthday party. I was like, well, then this guy's connected. And he was excited about the inflator project, which I had nothing to do with. And then I found out the Runnymede Playhouse was his uncle's. So I'm going, wow, the Runnymede Playhouse was your uncle's playhouse. All right, so he convinced me that he had, you know, the means by which to maybe make the project work. His son and daughter both worked for Delphi, where the inflators were. So I said, all right, I know a guy who's involved with that, and I introduced him to Chuck, and he gave the big sales pitch on Kettering and the great history of Dayton and inventing, And Chuck got excited, and I had to say, well, Chuck, he's the real deal, you know. And he says he can help us, and Delphi is going to help us. All right. So we formed a company, and he brought another businessman in, and we organized the company and wrote a different business plan for the inflator. And Chuck said, well, we got to find the funding, you know, and the original partners came in at that point. So we had a really nice business plan. We went out and we started presenting it to different people and spent a lot of time rewriting the thing over and over again, trying to figure out, oh, wait a minute, Chuck's trying to convince people that he can do it. Delphi already knows he can do it, but none of the business people in town were all that excited about risking any money to do it. So we went through cycle after cycle. And even though we had this great business guy, he wasn't putting any money in either. And so after running into a lot of brick walls, we were still working at Mound for a little while yet, and we formulated a company. And the new partner, the businessman, he gave us the best lawyers and the best accountants in town because they were his. And we were still excited for a while. And then we quit working and started the company. So right away, we saw the opportunity from Mike because Mike knew everybody. When he called the plant manager at Delphi, the plant manager called him back. So they were interested in helping us, and we decided to keep plowing ahead, and Mike had connections. So now we're scrambling. It's like we don't have any money and we can't seem to get anyone interested in our business plan, which showed us ramping up, inventing an inflator, patenting the inflator, eventually hiring like 1,500 people to build it in Dayton. That was our business plan. It was like, well, it was way too ambitious. And we didn't think of it that way, but because we just got done doing some of the hardest things anyone could possibly do. And we knew we could build a device, and we had every confidence because, you know, the Mound philosophy was, if you want something to accomplish, give us enough money and time, we'll do anything you want us to do, because we've done it before. But we couldn't convince anybody else that was possible. So they're like, all right, what are we going to do now? So we looked at consulting, and we brought in all the other Mound businesses to do projects for Delphi. And we started knocking out 20-year problems, right and left, because again, Chuck's capability, looking at everything we had, he could do it. So he brought in like a series of other Mound companies, and we were doing consulting. And then I went out and worked for Monarch Marking for like 8 months. And then I went to Process Equipment because Gibbons knew them. And I was doing my own consulting. He was doing his own consulting. And then we said, hey, what else are we going to do? We eventually wound up down at Testfire, renting that facility, and running out of money. But Chuck we'd go to the auctions on weekends. All the Mound equipment was out there, the auction houses. And Chuck got excited, hey, you know what, I need this, I need that. But in order to get this or that, you had to buy a whole pallet full of stuff. So we bought these pallets full of items at a real cheap cost on our own money, because no one was investing in us. We're using our money and putting it in giant trucks and driving it back through the gates. And the guards would meet us at the gate, so what are you bringing in here? And they looked in the back and said, that's all the stuff we just shipped out of here. And then you're bringing it back in. Well, yeah, we got to have a company here, so we need equipment. So we drove it back in and put it in. And then went out on eBay and sold everything we didn't need. So we bought the things we needed and sold everything else off, and then used our own consulting to try to keep us floating. And at that point, I went after an MBA because Mound gave us some money on the way out the door, and it could only be used for education. I thought, well, if I'm going to have a company, perhaps I should finish my education as an MBA. I needed the experience. So while I was getting the MBA, I met a fellow named Mark Merton who worked for the Dupps Company. And as we're talking, I'm looking at things that Chuck could do. I said, hey, you have any metallurgy problems over at Dupps? And you got any metal? He said, everything we make is made out of metal, giant metal things that break all over the place for rendering equipment, which then the acids eat all that stuff up. He said, well, sure. So I said, you want to meet one of the best metallurgists you'll ever find? Let me introduce them to you. So I did. And Chuck went over to see what their problems were. And while we were there, you know, he saw they were trying to take two different metals and cast them together. They were having a tremendously hard time doing that. They didn't know how to do it. So within a few months, Chuck showed them how to do it. That's still one of their main products, is a dual alloy casting to make screws. And the screws had to withstand acids, and they had to withstand the beating, because out in the rendering plants, they're throwing everything into that big grinder to make dog food and cat food and cook it up and make things out of it. But Chuck had the ability to show them how to make that alloy work, and then he was looking at other alloys and other problems they had. And Mark then said, well, one day we were having a beer after class, he said, if you need somebody to work for you, Fred Sager over there is really impressive in his ability in engineering and things he does, and he's also building computers. All right, so I saw Fred, and I said, sure. We could use some employees, because Chuck needs a lot of help, and I'm busy running around with all the business aspects, and he's doing all the other heavy lifting. So we got together. So I got Mark Chuck, and Chuck got me Fred, and there we were in test fire. So we finally hit our heads against the wall so many times that we discovered that Mike didn't really have the family fortune anymore, and we're a little disappointed in that, but we didn't know. And the business guy he brought wasn't interested in risking much of his money, so there weren't any funding for what we were doing. And Mark said, hey, you know, if you cut these patterns that we use to make the screws out of foam, we could save a lot of money on tooling. So if you could make a 3-axis piece of equipment and cut these out of foam in cold tolerance, you know, we make these screws all different sizes, and we have to buy $30,000 tooling, and we only need 10 of these a year. It'll take 10 years to pay it off. So if we can make it out of foam. So Mark had all these great ideas on how to save them money, and of course, anytime you ask Chuck to do something, I was like, sure. You know, everything was yes during those early years, and then after Mark would leave, he'd go, how the hell are we going to do that? And then Chuck bought all the things he needed in pieces, and computers, and 3-axis devices, and threw it all together and made a machine and a special tool. CAD integrated with the CAD system. Pretty soon we're cutting tapered screws right and left. So that became our first foam project. And Dups was happy, and the foundries were not happy. And we thought, hey, we got a niche here. They should do this. It'll save them money. No, the foundries didn't want to do. They've been doing what they do for 100 years. You know, they're not interested in anybody saving them money, because they know how to. Plus, they have your tooling. So if they have your tooling, they have your business. And we just broke free of that and said, we can make any screw out there that you bring us. So all the competitor screws, we can make them all one at a time. And Dups was extremely happy about that. So they said, Chuck wanted to sell them the equipment, and Mark said, why don't you just make us the screws? We need 50 of those, and 100 of those, and 50 of those. So pretty soon we're bringing all that into test fire. And we decided to end the partnership because we were running out of money, and the foam really wasn't getting started yet. So Bernie Kokenji said, if you ever need help, just let me know. So I said, hey, Bernie, we need some help. We're out of money, we're out of time, and our consulting and other things just wasn't making it happen. So he said, I know a guy who'll help you out. He's at Henny Penny. His name's Jack Cobb. And Jack became our angel investor. He saw what we were doing, and he saw Chuck, and he said, hey, I need all this help at Henny Penny I could use on processes and welding and all the things they do there. So he said, all right, I'll support your business, and Chuck will help me solve Henny Penny problems. So he bought out the other two partners, and they stayed friends. You know, we still used Mike. Mike had all the connections, and he was a great guy. He was our cheerleader. He was real proud of us and wanted Dayton to be successful. So after a while, as we were cutting foam, we were bringing billets in, which are billets are 4 foot by 4 foot by 8 foot. They didn't fit through the doors hardly down in test fire. And Chuck, in the meantime, was going. Before Jack came, he was going out to Illinois on weekends, and he was making that inflator on a shoestring. So Chuck was already working on the patents. And we had no money to pay for them. So he proved it worked. But what Chuck did, and as Chuck will do, is because he didn't have the money to do the physical testing, he did it all on computers. He did it all in simulations. He created the technology with all the physics equations. And he already knew it would work before he even built the first inflator. So Delphi was happy, but what they were doing at that point was they were sending us all the other inflators from all the other manufacturers so we could test them. And so they were funding us through testing. And we were showing how Chuck's inflator was better than all the ones out there. He actually went in there with the previous partners, and Delphi gave him a laundry list of what they wanted that thing to do. Chuck wrote it all down, and before long, he had that thing running leaner and greener and faster and quicker and less expensive to manufacture and less hazardous to build, and it outperformed what they had. Because when we would videotape those things at high speed, and I think still maybe today, those things have a flame front that shoots out of them in order to generate the energy it took to blow up the bag. Well, Chuck had a way of mixing the chemistry in his own gases that would accelerate and bring out the moles of gas into that bag without that big flame front. And he showed them they could work. Well, then after a while, and he finally got the first patent after Jack came in, then he decided, Delphi decided, well, that's great. I think we're on the path here, but that's not good enough. It's like, because they were a little reluctant at that point to really take on TRW. They didn't build their own inflators. They bought them from Takata and TRW. And here Chuck had already solved it for them. It was a little quick for them. And they said, well, that single chamber device is great, but it's the same as the rest of the guys, only better, cheaper and better and everything. He said, so we want the multi-chamber device. We want something we can put anywhere in the car and have a multi-chamber and blow up a bag with that. So, all right. And they started giving us more and more and more testing to do. So, all right, whatever you want. We finally gave up on the idea that we were going to build this thing. Delphi then agreed, after we went to our new location in Franklin to expand for the foam, Delphi finally agreed to a contract for development and paid us the upfront money, and we were able to pay our investor back because we were digging a hole in the ground at that point. And so they decided we're going to really fund you guys, and we agreed to a contract that if you can develop this thing and build it, then you get so much money per inflator when it all goes into production. And they brought equipment down and power to the building, and we were on our way. In the meantime, we had other development projects. Chuck was scrambling around, but Phelps had things to do, and let me get in my pocket here. I cannot do Chuck justice enough. I know the presentation is mostly about the foam, but when you look at all the things Chuck did in the meantime, I'm just got a list here. While we were doing the foam and eventually building the business on that side, Chuck had a project on a plant up in Springfield that said, we have these giant pumps up there in the Arctic Circle, and we have to change the spark plugs on them all the time. And is there a way you can put iridium on the tip of a spark plug to make it last longer so we don't have to go up there and shut those things down? They're real expensive. So Chuck did that for them and showed them how to put iridium on spark plugs. First time I know anybody ever did that. Within a few years, they were putting them on race cars. And now when you look around, nobody changes their spark plugs anymore. Well, I don't know where that started, but it could have started there because they didn't know how to do it. And he did it for them. The iridium that you used to encapsulate plutonium for the batteries and the space probes was used to make spark plugs last longer. And he then when we were working on the dual alloy in that, he created an alloy, or I don't say created, he said he discovered it. This knife here illustrates his alloy called Wood's alloy. Well, he made a screw they couldn't break, and he discovered it accidentally. He formulated something, and we were going to test it and show it to the customers. And when he made it, we sent it up to the shop to cut a dog bone off of it to pull test it. And they said, we can't cut this. What's it made out of? He said, okay, well, it's too hard. All right, can't cut it. So he said, I'll anneal it. So he had his own furnaces down test fire, and he tried to anneal it. He said, all right, here you go, try it again. It's exactly the same. He said, well, it can't be. Well, all right. So he took it through a super annealing, heated up to 1,000 degrees C and step cooled at 100 degrees every hour. Whatever the super annealing process is, sent it back to him. They said, this is exactly the same. He said, it can't be. Finally, he was able to saw a chunk off of it and look at it. Well, it's through hardened material. It's tempered martensite through the whole casting, right out of the casting. So it's like, wow, what are we going to do with that? You know, we need funding. You know, again, no back to the funding. So at some point, he went up to demonstrate it. He said, we can make tooling out of this. So we cast injection molding tooling from a foam pattern to an injection molding press and machined the final finishes on it. And it didn't need any heat treat. It was already hard as heck. So they ran it through the process, and then again, we look at the people who make tooling and they went, we don't make it that way. We don't cast tooling, we machine it. Well, yeah, but you could cast it. You know how much money? There really wasn't any big investment in town. They already knew how to do tooling the old-fashioned way. They machined it out of tool steel, and then they hardened it, and then they had to grind it and polish it again. And we said, well, you can skip all that. So then we're looking around for applications for this alloy. So we went to Dupps, no, not Dupps. We went to BIMAC, the casting house we were working with. And they had a decorative pattern to make decorative knives with. And so we said, can we borrow that? Because we want to make a knife out of with Chuck's alloy. And there was a knife guy who was a customer of ours. He said, man, that might be good for making knives. So Chuck decided to go make a knife for him. So he made a bunch of these. And so the knife guy said, well, that's really cool looking. It's Rockwell 45, all right. This is as cast and this is as polished. Well, it polishes up like chrome. It's got a lot of chromium in it, but it's not considered stainless because it doesn't have enough of that. So the knife guy said, all right, that's really cool looking. He said, but it's not hard enough. Knives need to be Rockwell 60 to hold an edge. So Chuck took it up to Winston heat treat, said, put that in there, we're going to carburize that. And the Winston guy said, that's going to curl like a pretzel. He said, go ahead and do it anyway. Came right out looking the same because we knew it would. And they said, all right, now it's Rockwell 60. Put an edge on that thing. And the knife guy said, well, that's really great. A cast knife. You know, they don't cast knives because the materials aren't right for that. So he said, well, knives are real brittle. He said, well, yeah, it's kind of brittle, but not. We already tested it. We knew it wasn't, the toughness was beyond the brittleness. He said, well, what's going to happen if I hit that with a sledgehammer? I want to break. Chuck put it in a vise, gave him a 5-pound post maul and said, see if you can break it. And he couldn't. He just dented the post maul. Now what are we going to do? Well, we're going to go look for funding. Yeah. Couldn't find the funding. So we expanded our EPS capabilities and our staff, and we started hiring people. Then we relocated from Franklin over to the net folding box building in Dayton, North Dayton, with the Mound Manufacturing Machine Shop, 46,000 square foot. And we went in there together to expand our foam. Chuck had his own area for inflator testing. But then we started looking at how are we going to do our business structure. My MBA was progressing. I used all the knowledge that I knew from working at the Kroger company, from how they operated with the tight profit margin, how their management style was very rigid and very detail oriented. And then I looked at how Mound operated. It was kind of like the opposite. I come to Mound and it's a matrix management. All the focus is out on the product, out in the areas. The management was truncated at the top. It was the people out here in the field were the ones doing everything and managing everything. So it really was like a self-directed work teams and individuals. which is really how the power of Mound, the matrix management. The power of Kroger was their structure. So I knew that taking care of the employees was extremely important. So we created a 10% profit share and 100% medical insurance, 401k matching, and we wanted to keep all our employees as long as we could. So we gave them a nice work environment. We focused really hard on customer service and speed. We didn't want competition, so we kept a real low overhead, and with the help of Fred, we were totally integrated. I mean, like Mound was. We had everything we needed among the individuals of the company. We had the ability to build the machines, fix the machines, run the machines, and then on my end, I automated all the business functions with QuickBooks and every function they provided. We could do our own payrolls. We didn't need any services from anybody outside. So with the machines we built and ran, we had a lot of repeat business, including small to large companies. We had aerospace companies call us. Now the things we learned, like at Kroger's, Eileen was in the tax department, she was a corporate secretary, I was in operations. At Kroger's, everything was speed, and it gave them that competitive advantage. And little things mattered to them, like the phone ringing. We answered the phone. We never let it run the voicemail. So anybody calling us up, the phone was answered, and people got answers fast. They got quotes fast. So we wanted to maintain that. So with that model, we kept our employees, we kept our customers, we kept our suppliers, and we just pounded it for double-digit growth for about 10 years. Expanded it in 7 markets. We had, by that time, we had 2-axis, 3-axis, 4-axis routing and hot wires. There wasn't any shape we couldn't do. We were actually doing 5-axis machining, because with foam, you don't have to hold it like you're doing a machine shop. With foam, you could reposition it, glue it together, and sand it. So our competitors were like Disney World, where they had 5-axis gantry robots. And we were doing it with small hand machines and 3-axis, 4-axis machines. So we could compete with them. And then we had a variety of EPS densities and dowel materials. And then we went and got ourselves a densifier, because when you cut 1-pound polystyrene, we could fill a whole building full of, but we found that we could densify it, recycle it, resell it 20-to-1. So we got densifiers so we could not fill our dock up with foam. Then we found coatings to use for signs and displays, and we found the least cost coatings we could find to expand into those markets. So we expanded in. We had architectural shapes was the first big market we had. The foam company was our competitor, and they were also our supplier, and they weren't real happy at first when we started making shapes for architecture down at Franklin. But after a while, they could see we could do 3-axis. They couldn't do 3-axis. So every time they got something they couldn't do, they wanted the job, so they give it to us, and we'd make 3-axis round spheres, giant baseballs, tapered baseball bats. They couldn't do that. So after a while, they got tired of fighting with us, and pretty soon we were doing all of it. So they just sent it over, and they just sold foam by the truckloads, because that's really what they did. So we found we could do concrete forms, we could do signs. So we found that everything we could possibly think of, you could use foam for: decorative shapes and amusement parks and sculptures. And Tom Shushia came. He's one of our most exciting customers and a good friend. And he was our first sculptor to use the foam process, and we'll get to that later. Prototypes. We made prototypes for trade shows. When somebody hadn't made a product yet, but they wanted to know what it looked like, and it was really big, we could make it look like the product, and they could take it to the trade show. One company was one of Jack Cobb's other companies, rotational molded plastic, was making like tornado shelters, and those things were like 8 foot in diameter, and they hadn't got their tooling done yet, but they wanted to sell it ahead of the tooling, so they went to the World of Concrete over in Vegas, and we made them one that looked just like the real thing, and painted it, and they took it down to the show and helped them sell their products, and that became another niche. along with things for aerospace and Wright Pat. We made all kinds of things for Wright Pat, drones and things. Then packing, the net folding box company that we bought the building from made packing, so they became our customer for packing materials. And then of course we kept the metal casting patterns for ducts. We really didn't see a lot of expansion in that. So at this point, I'd like to go into the secrets to our success. As obviously we had a customer focus, talented staff, totally integrated. We had the benefits. 100% medical insurance, we didn't even know at the time, most companies don't even offer that anymore. But we thought it was extremely important, and as the cost went up, we absorbed it. But the 10% profit share, those guys, they ate that up. So that with the medical and the profit share, we didn't have to give raises. They got raises by growing the company. That works. Always wanted to do that. I probably should have made it 15%. And then of course we had a 10-hour work week. Guys could come and go as long as they got their work done. Sometimes they didn't get there on time. Sometimes they were kind of, a few guys didn't work out too well and the other guys didn't like, because it's profit share. Every dime we made was theirs. And if they screwed up, if some guy came in and didn't work out, they just didn't stay around long because the rest of the guys, they wanted to make their profit. This is the integration. Eileen did the web page. We did our own accounting. Fred did the networking on the computers. We didn't need anybody outside the company. And Chuck, or Fred, at this point now it's Fred, could fix all the machines and remodel them and improve them all the time. So we were constantly, we did find out that the EPS phone company really didn't like us taking their business, so they went out and bought a 3-axis giant CNC EPS machine. We didn't even know they had it. And then until they called us and tried to get us to buy it. And we went over to look at it. And the thing weighed like 2,500 pounds. And the machines Fred and Chuck had built, most Fred now at this point, our machines were just standard machines. They were real lightweight and they were built specifically for what we did. So we didn't have to buy an off-the-shelf giant foam machine. So that kept our overhead low. And so we didn't have any competition. And after my MBA, and I'm trying to be Mr. Sophisticated, I realized that we could maintain a 30% profit share. Now most machine shops will take about 8 to 10% profit share. But we know if we maintain 30%, we weren't gouging our customers, and we were making money at a pretty good clip. So we had real-time accounting, so every time we did things, every month we knew we were making profit. We made profit for like 10 years in a row, and the company grew and grew and grew. People became really productive. Man, we were growing too fast in some ways. So we decided, we didn't decide, but Chuck had done some really amazing things, but by the time he got the the multi-chamber inflator done by 2007, Delphi was out of gas, and they went bankrupt. We were at the point where he was through development. The inflator was ready for production. All you had to do in production was run a bunch of series of the same tests. The product was designed. It was through development. There was nothing to change on it except go through the motions for NHTSA. And it was going in cars. And Delphi went, we're done, we're bankrupt, So they couldn't pay us the rest of the deal they were going to pay us. They put all the money on the tail end of it, and they never got to the tail end of it. So Chuck was kind of stuck, In the meantime, I meant to throw this in somewhere, but he had taken his inflator technology, went over to Armalite, where he did a lot of his testing, and he did contracts for them, and figured out how to make bullets go faster. He took his accelerant from the inflator and put it in the chamber of a bullet and took half the powder out of it and made the bullet go 50% faster. It was a giant leap forward. Of course, General Dynamics owned the technology. You couldn't patent that. But it was just amazing what he was capable of and how little credit he got for all that. So then Delphi went bust. So we were looking at each other like, now what are we going to do? we've been this far, so all the foam took off. It's like, all right, why don't you just, Jack was involved in the last of this and said, well, why don't you just split up and you stay in the building and, you rent from Bill, and then we become two separate companies because you really don't fit together anymore. We can't find the funding for what you do. You're still making plenty of money doing the consulting and anything you did for Ethicon and the base and anything else you were doing, and we were doing our thing. So we split, and we got a new chairman. Jack stepped out, and the Neff folding box, Bob Neff came in. He became our chairman and gave us advice at that point. And Chuck went out on his own. But now I want to just illustrate, this is probably a fun time, is the things we worked on that people would recognize: the highway murals, the amusement parks stuff, Scooby's Haunted Castle. The spire was like 10 feet tall on the top of that building, and we made almost everything on it. And of course the big Jesus. The first one burnt down. We had nothing to do with the first one. We discovered that the foam they used wasn't fire retardant because it wouldn't burn like that. Our foam had fire retardant. And so Tom Shushia, we pulled him together and worked and he worked and then created the statue, and it's better, and it's got 2 lightning rods in it. So it's still there. Yeah. And architectural pieces around town you might recognize. Holtzman done. We made these really crazy signs. We love to do these things. That's down there at Union Center. Christmas tree shop. We did all kinds of things on buildings everywhere. A lot of monument signs. I always thought we could just do monument signs and make a pretty good living. This part is real stone and that part is fake. But we had some of them, like in Beaver Creek, where we made the facade out of brick, and it looked like real brick. That one's real stone. Because Miamisburg said, you can't bring that monument sign to the ground like that. You have to have a concrete base under it. Even though the thing only weighs 30 pounds. You couldn't convince them. They had their rules, so they had to build a real stone base under a 30-pound sign. All right, whatever. That's a 15-foot tall, 12-foot tall. Fred made this for a trade show for Hasbro, and it stood up. It was Legos. Yeah, elephants. Concrete in Springboro wanted us to make forms for them because mainly one of the secrets to our success was we were replacing wood and steel with foam. And you can still get a pretty good look to it. So Concrete Technology in Springboro was wanting to bid on these kind of shapes, and they couldn't make them with their regular shop out of steel and wood. It took them too long, and we could do this within weeks. So they said, well, if it weren't for you, we wouldn't even build on this building in Chicago. So we were doing a lot of things for them. Then we had local guys in Springfield that did parties and trade shows, and so we were making, and this is them finishing this. The Woody, we just made really cool things for. And then this is one of my favorite projects, the UC Bearcat, that Tom Shushia, he was a sculptor, and we made one Bearcat and coated it, and it wasn't good enough because it was still foam, and the people and the kids around there were going to tear it up. There was nothing to stop them. So eventually they remade it out of bronze. So it's going to stay there now. Nobody's going to beat it up. We made things for the Reds. This is some of the more fun things we did that you might recognize. That's hanging it's still hanging up in the Hall of Fame. Then from Johnny Bench onward, we worked with Tom on all the Red statues. P. Rose. And then they decided to do a documentary on the process. Now, this guy right here, right there is me. And that made it into Sports Illustrated. So I'm in Sports Illustrated. So they decided to show this in their Hall of Fame for a year and show how the process started when I wanted to introduce this. The whole reason to do it this way was to save money and time. It used to be Tom would make a small sculpture out of clay, and then he would then have to take that and turn it into a full-size sculpture out of clay. And that clay, I don't know how much it weighed, 400 or 500 pounds, and it took a long time to do. I said, well, if we could machine the foam, we'd take the small thing out of clay, scan it in three-dimensionally, and scale it up, make it out of foam. And then you just put the clay over the foam. And that was the big secret to saving time and money. So now I want to see if this works. We'll see if this runs. Let's give it a minute. So they made this documentary.
It is fitting that it is baseball, our national pastime, that has produced some of the finest sports sculptures in the world. In doing so, our national pastime has perpetuated a tradition that dates back to the ancient Greeks, who were the first to honor their great athletes with bronze statues. In the birthplace of professional baseball, only 9 players from the long history of the Cincinnati Reds have been immortalized in bronze statue form. The first 4, Ted Kluszewski, Joe Nuxall, Frank Robinson, and Ernie Lombardi, were chosen by the fans as being the best representatives of the era when the Reds called Crosley Field home. This quartet of statues was installed at the main entrance of Great American Ballpark in the first 2 years of the park's operation and continue to welcome fans amidst their pickup game in a setting that evokes Crosley Field's famous sloping outfield terrace. Since 2011, the 4 Crosley greats have been joined at the ballpark by statues of Johnny Bench, Joe Morgan, and Tony Perez, 3 of the stars of Cincinnati's fabled Big Red Machine. And in July of 2015, a statue of Chuck Harmon, who broke the color barrier with the Reds in 1954, was dedicated at the Reds P&G MLB Youth Academy in Cincinnati's Roselawn neighborhood. Each of the subjects of these statues share in common major contributions to Reds history. They also share a creator. Cincinnati native Tom Sushia is the artist responsible for each of the Reds statues. Sushia's approach to creating these works of art has changed little over the years, and a look back at the creation of the Johnny Bench statue provides a clear view of the many steps that must be completed in order to turn a red into a bronze. For Sushia, it all begins with research. He pores over books, images, and film footage to determine the characteristics that made the player so special. Out of this research emerges design concepts that are reviewed by the Reds, the Hall of Fame, and, when possible, the player himself. For the bench statue, Johnny agreed that a throwing pose would be best. It was then left to Sushia to create a design that captured Bench in action, and action was imperative, for Sushia wants his works to exude energy. The static, solid image that the word statue often evokes is not what Sushia strives to create.
About maybe 2010 or 11, I got back on the project because the Reds announced doing some of the Big Red Machine guys. And I wanted each of the Big Red Machine guys to be unique from the other ones, and each of them cool and distinct and capturing their best moments or spirit in the best ways.
Sushia spends several months perfecting a small version of the statue out of clay. This model undergoes countless alterations before it is finalized. Once finished, the statue is delivered to Exact Metrology, a Cincinnati-based company that produces a 3D scan of it, creating a computer model that depicts the statue from every possible angle. The computer file is then sent to Global Foam of Dayton, Ohio, a company that makes shapes and figures out of foam. At Global, a full-sized foam version of the statue is created. The foam form is shipped back to Sushia's Cincinnati studio, where the artist and his assistants apply a layer of clay to the foam form and begin the process of detail sculpting. placing special emphasis on the details of the face, hands, and uniform. Once the detail sculpting phase has been completed, the clay-covered foam statue is shipped to Indianapolis-based Syncaris Bronze Arts Center, the foundry that will cast the statue into bronze. Once at the foundry, a wax mold of the statue is created. The entire form is coated in wax and is then cut into pieces. Each piece is dipped into a slurry solution that, after hardening, encases each piece in a hard ceramic shell. The pieces are then placed into an oven that is heated to roughly 1,000 degrees. Inside the oven, the wax inside the ceramic shells melts away, leaving behind a detailed imprint of the piece in the ceramic shell. This is known as the lost wax process. After the wax is melted away, molten bronze is poured into each of the ceramic molds. After the bronze cools and hardens, the ceramic shell is chipped away, and the individual bronze pieces are then welded together to form the statue. Members of the foundry staff smooth out each of the welds to eliminate all visible seam lines. The next step is the application of the patina. It is the patina that gives the statue its distinctive color.
Unfortunately, if you polish up something like a raw bronze and you let it sit out in the public space for even like a few days, it's going to turn like usually dark and like gray or whatever. So what the foundry does is applies chemicals to that raw bronze and they brush it on there, and then they heat treat it, and what it does is it creates that chemical reaction, and it creates this film as a result, and then it protects the metal.
The application of a protective wax is the final step in the foundry process. Roughly 2 months after the clay-covered foam form's arrival, the completed bronze statue is transported to its new home. For the Johnny Bench statue, that home is located right outside the entrance to the Reds Hall of Fame and Museum. The morning of the dedication, a crew of Red staff took charge of the installation. With its unveiling that afternoon, the year-long process of creation had officially come to an end. Like the 4 players who preceded him and the 3 who have followed, Johnny Bench had been transformed into a work of art. And soon this select group will be joined by another Reds icon, Pete Rose, whose statue will be added to the impressive array of Reds immortals that greet fans at the entrance to Great American Ballpark. Awaiting Pete on his statue's dedication day is a feeling like no other. For all of the honors each of the Reds players honored in bronze achieved, nothing quite compares to this.
I've been looking forward to how appreciated I am this day, today. But I can find none of them feel right. They all are too small.
My plaque hangs in Cooperstown, but for me, this is probably my greatest moment.
The ultimate goal of every player who's ever played this game is to get to Cooperstown. And that's the way I felt that day. Well, you know what, Johnny, you were right. Today is a better day.
You know, the old saying is, they said, once you leave home, you can't come back. Well, you all have proven that wrong today. The statue says that you can come back home. I am home. Thank you.
There is nothing like going from red to bronze.